Turn off every light, close every curtain, and make the room completely dark. Now hold your hand in front of your face. You cannot see it, but your hand has not completely disappeared into the darkness. At this very moment, your skin is producing real photons. Your face is glowing. Your chest is glowing. Even your hands are releasing tiny flashes of light. Welcome to EXEPEL, where science reveals the extraordinary secrets hiding inside ordinary life. Today, we are entering a world your eyes were never designed to see. A hidden world where every living person quietly shines in the darkness. This is not spiritual energy, radiation from a phone, or heat detected by an infrared camera. It is measurable light produced by chemical reactions inside living cells, and scientists have photographed it. In 2009, researchers Masaki Kobayashi, Daisuke Kikuchi, and Hitoshi Okamura placed 5 healthy young men inside a completely dark room in Japan. The experiment required extraordinary equipment because the light they were searching for was incredibly faint. It was approximately 1,000 times weaker than the minimum brightness detectable by human eyes. A normal camera would see nothing. The researchers used an extremely sensitive charge-coupled device camera, capable of detecting tiny numbers of photons. To reduce electronic noise that could interfere with the measurements, they cooled the camera sensor to -120 degrees Celsius. Each volunteer first had the surface of his body gently wiped. He then waited inside the dark room for 15 minutes. This allowed light temporarily absorbed from the environment to fade, reducing the possibility that the camera would mistake leftover illumination for light produced by the body. The volunteer then sat motionless, naked from the waist up, while the camera collected photons for 20 minutes. Scientists repeated these measurements every 3 hours, beginning at 10 in the morning and ending at 10 at night. The experiment continued for 3 days. When the images finally appeared, the human body was no longer completely dark. It shimmered. However, the light was not equally bright everywhere. The face released more photons than the chest. The strongest emission appeared around the cheeks and mouth, while the sides of the face and the areas around the eyes were dimmer. Even stranger, the brightness changed depending on the time of day. The volunteers glowed weakly in the morning. Their photon emission gradually increased throughout the day and reached its highest level at approximately 4 in the afternoon. The glow then weakened during the evening and remained low throughout the night. At its afternoon peak, photon emission from parts of the face was roughly twice as intense as it had been in the morning. The human body appeared to possess its own daily light rhythm. But perhaps the camera was simply detecting body heat. To investigate this possibility, the researchers compared the photon images with thermal images. The two patterns did not match. The warmest regions of the body were not necessarily the brightest photon-emitting regions. Changes in body temperature also showed no significant connection with changes in photon emission. The camera was not merely photographing infrared heat. It was detecting actual photons associated with biochemical activity. So where does this mysterious light come from? Every second, your cells perform an enormous number of chemical reactions to keep you alive. They use oxygen, process nutrients, repair tissues, maintain organs, and release energy. During ordinary metabolism, reactive oxygen species and free radicals can form. These highly reactive substances can interact with fats and proteins, sometimes creating molecules in an electronically excited state. Imagine a molecule temporarily holding more energy than it can keep. When that molecule returns to a lower energy state, it must release the excess energy. In certain reactions, part of this energy escapes as a photon, a tiny particle of light. One photon is invisible. Even hundreds or thousands of photons released across a small area of skin are far too faint for human vision. But a sufficiently sensitive camera, operating in carefully controlled darkness, can collect those photons over time and build an image. The glow may therefore provide a faint optical record of chemical activity occurring inside the body. The researchers also collected saliva from the volunteers and measured cortisol, a hormone that follows a strong daily rhythm. Cortisol is generally higher in the morning and decreases later in the day. photon emission moved in the opposite direction. It was lower in the morning and stronger during the late afternoon. The researchers found a statistically significant negative correlation between cortisol levels and photon emission. They proposed that the body's glow might be connected to changes in metabolism controlled by our internal circadian clock. This means the brightness of your invisible glow may not remain constant. It could rise and fall as the biological clocks inside your cells regulate energy use throughout the day. However, there is an important limitation. The original experiment included only 5 healthy men in their 20s. It showed that ultra-weak photon emission could be photographed and that it changed rhythmically in those volunteers. But it did not prove that every person glows with precisely the same pattern. Larger studies are still needed to determine how age, sex, diet, sleep, stress, medication, illness, and environmental conditions affect this light. Scientists are also investigating whether ultra-weak photon emission might one day help monitor oxidative stress or reveal changes associated with disease. Because the light is connected to biochemical activity, it could potentially become a non-invasive source of information about the body. But this research is still developing. There is currently no established medical camera that can diagnose your health simply by photographing your biological glow. The scientifically proven fact is already astonishing enough. Living cells can release photons as a byproduct of biochemical reactions. Human skin produces an extremely faint form of this light. Sensitive instruments can detect and photograph it, even though our eyes cannot. You are not glowing like a lamp or a firefly. Nobody can see your light by simply staring at you in a dark room. But the photons are real. So tonight, when you switch off the lights and the room appears completely black, remember something remarkable. You have not completely vanished into the darkness. Your body is quietly revealing the chemistry of life, one invisible photon at a time. If this hidden scientific mystery surprised you, subscribe to EXEPEL and turn on notifications. Share this video with someone who still believes the human body becomes completely invisible in darkness. More unbelievable but scientifically proven discoveries are waiting for you here. Until the next mystery, keep questioning what your eyes cannot see.